Alright guys, I'm going to give you a quick little video on series and sequences. This is from 6.5 and actually have it in the reverse order. It's sequences and series. Um, there's two types of sequences and series. There's arithmetic sequences and series, and there's geometric sequences and series. The difference is when you're talking about arithmetic, you have a common difference. So that means the terms have a common difference, like they're like from one to the next one, it could be a difference of like two or three or five or whatever it is, and that all the terms have that same difference. When you're talking about geometric sequence and series, the terms differ by a common ratio. Okay, so on the first one, we're gonna do number one. So we're given a sub n equals 4 minus 5 to the n. So this is how you decipher this. First of all, this number right here, whatever you're adding onto this is your first term, a sub n. This is my terrible arrow right here, which you're multiplying times the n. This is your common difference, denoted by d. And if we're trying to find the first 5 terms, I literally am just going to put in the different numbers from 1 to 5, and then we also want to find the 52nd term. So I'm just going to list these out right here. A sub 1 to 5, as well as I'm throwing in the a sub 52 just because we're being asked for it here. And so for this formula, all we're going to do is change the n. So we want a sub 1, all we're just going to do is plug in 1 for n. 5 times 1 is 5, of course. 4 minus 5 is negative 1. And if we plug in 2 for the second one, 5 times 2 is 10. 4 minus 10 is negative 6. For the third one, plug in 3. 5 times 3 is 15. 4 minus 15 is negative 11. And so on. So when we plug in 3, we're going to get negative 11. Plug in 4, we get negative 16. We plug in 5, we get negative 21. This is negative 21. And we put in 52 for the 52nd term. 5 times 50 is 250. 5 times 2 is 10. 250 plus 10 is 260. 4 minus 260 is going to be a negative 256. So here we have our first 5 terms. Negative 1, negative 6, negative 11, negative 16, negative 21, and negative 52 for the 52nd term. Now number 5, this is also arithmetic, but in this case we're going to be find the series. Now literally we could list all the terms out here, starting from 1 all the way to, this is going up to 50, so we could list all 50 terms and then add them together. We can do it very easily, but that's very, very time consuming, so instead we're going to use a nice little formula. So here we're going to use this formula here. So I'm going to say the sum of, all the way to m is going to be m over 2 times the quantity a sub 1 plus a sub m. So the way you look at this is, what are we going up to? In this case, we're going up to 50. So here, our m is 50. And our first term here, we'd have to plug 1 in here. 9 times 1 is 9 minus 15. That's negative 6. And then, of course, we want to get the last one. So we're going to have to get a sub 50. So just plug 50 in here. So we're going to find those two terms first, and then we can plug these in. So if we plug in 1 here to get the first term, we're going to get negative 6. So we plug in 50 to get the last term. That's going to be 450 minus 15, which is 435. So now we can find the sum of this series. So using the formula, 50 over 2 is going to be 25. And negative 6 plus 435 is going to be, that's going to be 429. And if we multiply these together, we are going to get 10,725, and that is going to be the sum of that series. Okay, numbers 9 and 13, we're talking about geometric. So on 9, remember these are just listed out. This is a sequence. 13, you're actually adding them all together. This is a series. So remember, when you're talking about geometric, these have a common ratio. When you're talking about arithmetic, this had a common these had a common difference. So each term was separated by a common number. Here, if you divide one term with the next one, they're going to have a common ratio. So here you see 5 divided by 1 is 5, 25 divided by 5 is 5, 125 divided by 25, etc., all the way to whenever this finishes. So here I can say that my common ratio R is going to be 5. And we're going to need to find the explicit formula. Now your explicit formula is not too serious. It's literally just going to be a sub n is going to be that common difference, R, and this is going to be raised to the n minus 1. And that's it. So here if I plug in the common ratio, I can say that my explicit formula is going to be 5 raised to the n minus 1, and that's it. 5 to the n minus 1. That's your explicit formula. And we also want to find the 8th term. So if you want to find the 8th term, that means you're just going to plug in 8 in for n. So our explicit right here is going to be a sub n equals 5 to the n minus 1. If we want the 8th term, we're just going to plug 8 in for n. So we're going to have a sub 8 is going to be equal to r, which is 5 raised to the 8 minus 1. So this is going to give us 5 to the 7th power. And we're going to have 5 to the 7th power and 5 to the 7th power, 78,125. Okay, number 13, we're talking about a geometric series. So we're going to be adding all these terms up. If you can see here, what is your common ratio? 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided by 12 is 2, etc., etc., etc. And we're doing this for the first 7 terms. So when you're talking about geometric series, we have a nice little formula. S sub n is going to be the first term. In this case is going to be 3. This is a sub 1 times r to the n minus 1. Remember your common ratio here is 2 because 6 divided by 3 is 2, 12 divided by 6 is 2, etc. And then divided by the r minus 1. So our first term was 3, our common ratio was 2. So if we're going to evaluate the series, first term is 3, common ratio 2. 2 goes here on the bottom as well. Here 2 to the 7th is 128. So plugging that in here, we're going to have 3 times 128 minus 1. So here we're just going to have 3 times 127 divided by 1. So I don't even need to divide it by 1. And this is going to come out to 381. That's just like a quick little recap right here. Arithmetic sequence. You're just going to plug in these numbers to 5. These first 5 terms are your first 5 terms. Then you plug in 52 for the 52nd term. If you're talking about a series, you're going to use this formula. M over 2 times a sub 1 plus a sub m. You will have to get the first term. So plug in 1 and the last term to get the last term, and then you're going to plug these into the formula. So in this case, plug those in. It gives us a nice little number right there, 10,725 for number 5. For number 9, talking about geometric sequence. Remember, when you're talking about geometric, whether it's sequence or series, you're going to have a common ratio, and that's going to be your R. To get your explicit, this is just going to be the formula a sub n equals r raised to the n minus 1. And then for number 9, for those exercises, you're going to need to find the 8th term. Just plug in 8, and bam, that's what you got. When you're talking about number 13, you're getting the series. You also have a nice little formula here. It's going to be a sub 1, which is the first term right there. That's a sub 1. And you need your common ratio. Here we determined that our common ratio was 2. And this was going all the way to 7. So just plug in the 7 here and simplify. Bam, there's your series. All right, I know this is a little long. I hope that helps. Talk to you later.